Hello everyone, welcome to my chemistry channel B.L.DASH short and sweet in chemistry. Also I want to welcome the students at 12th science as my topic is coordination compound according to CBSE syllabus. Now today I am going to explain coordination isomerism. Then part 6C is coordination isomerism. You know what is structural isomerism. I have already explained in 6A and 6B. Structural isomerism means same molecular formula but different arrangement of atoms in that is called structural isomerism. That means structure, the arrangement is different. In structural isomerism, so many isomerisms are there. First one is linkage isomerism. What I have explained in part 6b, and now it is coordination isomerism, and remaining are that is solvate isomerism and ionization isomerism. Now in this part 6c, here I am going to explain that coordination isomerism. What is meant by coordination isomerism? This indicates that it belongs to coordination compounds. Two compounds should be there and where the ligands can exchange. See, for both cationic and anionic complex. That means here one should be cationic complex, other should be anionic complex. There should be two coordination compound. One is cationic complex, other one is anionic complex. Differ in distribution of ligands. Ligands, the distribution is different in the cation and anion. What is the cation present in first complex? What is the cation present in second complex? See, this is a combination of two coordination compound. The nomenclature is a big one. And here only when you see write the coordination isomerism, only the ligands distribution ligands will be changed by the interchange of ligands between two central metal ion, or you can say between two coordination complex, coordination identity. Let us see, when you see one example, it is clear to you. Let us see, this is one coordination compound where two coordination spheres are there. Two coordination spheres are there, having one is cation, other one is anion. That means this is a coordination compound where each one is anion and cation. So you know cation will remain, you should write cation first. That is why CONH3 whole 6 plus 3. That means CONH3 whole 6, it is plus 3. Why? Because ammonia is the neutral ligand, so cobalt should be plus 3. So the charge here superscript, that is plus 3. That means it is a cationic complex ion, not complex, cationic complex ion. Similarly here Cr, that is surrounded by Cn, 6 Cn ligands, and you know the Cn ligand is negative, that is why minus 6, and it is plus 3, so the charge of the complex is the minus 3. That means it is a complex, cationic complex that having plus 3 charge, and it is an anionic complex having minus 3 charge. That is a combination of two from here to here, that indicates one coordination compound. Then how to write is coordinate isomerism. Now see what is the name. First you will check what is the name. Hexaamine, another amine, cobalt 3, clear, cobalt 3, why? Because it is 3, cobalt 3, and this one hexacyano, but it is minus 3. If complex ion is minus 3, minus negative charge, what I told before, the metal ends in ATE with Roman numeral. So hexacyano chromate, chromium changes to chromate 3 because your oxidation number is 3, or you can say the charge of the central metal atom is plus 3. So again see hexaamine, cobalt 3, hexacyano, chromate 3. Next is coordination isomer. Then what to do? Only you change the ligands, or you can change here the central metal atom, same meaning. So here you change here by cobalt, take cobalt to here and write chromium here. You take cobalt from here to here and chromium here to here, or you can write this part change come to here and this part. But what happened? Why you should write this one? As because cation first you will write, anion next you will write. For that you see how can you write this is plus 3 and minus 3. Always remember, when you write its coordination isomerism, always you think, remember that cation complex ion, that means cation complex means plus 3 plus charge should be on the first left side and right side anion. So this is the result. Then what is the name? Again see, hexaamine chromium. Hexaamine chromium 3. There should be no gap, there should be no capital. Hexacyanocobaltate. Why it is cobaltate? Because the ion is anion, complex ion is negative charge. So cobaltate. What is the oxidation number? 3. So Roman numeral 3. So I hope it is clear to you. See here, for both cationic and anionic complex, it is applicable to cationic and anionic complex. And next, differ in distribution of ligand. This will come here and this will come here, or you can change only central metal atom so that this part again remain as plus charge. And by the interchange of ligands, so indirectly you can say interchange of ligands between two complex ions. But always remember, first the result should be, first part should be cation and next part should be anion. Left side should be cation and right side should be anion. So the nomenclature I hope clear. In first complex, what happens? 6 ammonia is attached to cobalt, so the result is plus 3. And 6 Cn minus or cyano group is attached to chromium. That is why the result is minus 3. This is cation, this is anion. In second complex, 6 ammonia that is attached to chromium. 6 ammonia attached to chromium plus 3 charge, cation first. COCN is minus 6. That means result is minus 3. That means here 6Cn is attached to, in second complex 6 ammonia is attached to chromium and 6 cyano attached to cobalt. So this is the result where it ends in cobaltate chromate like this, because this is anion part. Next we will see other examples which are very very important for the different examination point of view. We can observe here the second example of coordination coordination isomerism. Now in coordination isomerism, here two are present. One is cationic complex ion, here it is anionic complex. That means here positive charge, here negative charge. Then how? Because neutral molecule ammonia, so plus 3 and it becomes to plus 3. Oxalate ion, that is minus 2 into 3 minus 6, so it becomes to minus 3. Now what is the name? Hexaamine cobalt 3 trioxalato chromate 3. Chromate because it is anionic complex. And what is coordination isomer of it? That means here Cr, you change the Cr and that means ligand actually interchange, but this side should be positive complex, that is cationic, and this side should be negative, that is anionic. That is why you change this one, hexaamine chromium 3. Hexaamine, see here, hexaamine chromium 3 trioxalato and cobaltate, because cobalt changes to cobaltate 3. Why? Because here it is anionic complex. Now second example you can see, Cu surrounded by 4 ammonia molecule, and since ammonia is neutral one, so the charge here of the complex is plus 2. Similarly chlorido, that is minus 1, surrounded 4 chlorido groups surrounded by platinum, and it is minus 4. That is why the charge, sum of the charge in this coordination complex ion is minus 2. So it is cationic, it is anionic. You know cation always first, then anion next you will write. What is the name? Tetraamine copper 2 tetrachlorido. Since it is anion complex, that is a platinate. Again tetraamine copper 2 tetrachlorido platinate, and charge is plus 2, that is a 2 numeral, that is a Roman numeral. Coordination isomer is what to do? PT you take here. Hard example you see, 4 ammonia molecules are attached to copper, where ammonia molecule is neutral, so the charge here +2 and the all over the charge of this coordination complex +2, so it is cationic complex. Now PtClO4, PtCl4 chloride ion, that is -1, -4, so the charge is here -2 because the oxidation number of platinum is +2. This part is cation part, this part is anion part. What is the name? Tetraamine copper 2 tetrachloridoplatinate. Why platinate? Because it is anion complex. So that is why the metal, what is the metal that is ends in ATE with Roman numeral? What is coordination of it? Coordination isomer of it. That means here you write PT here and you write CUE here. Then what is the name? Tetraamine platinum 2. See, because it is positive complex, cationic complex. Tetraamine platinum 2 tetrachloridocuprate, that is 2, bracket in 2, that is called Roman numeral. Again, this is the coordination complex having positive and negative ion. And then now what is coordination isomer of this? You change the ligand, interchange the ligand, so ammonia should come to platinum, but if it come to here you can't write +2 sign, that is why you put PtNH3 whole 4. Now here also 4 chloride ion to the copper. So what is the name? Tetraamine platinum 2 tetrachloridocuprate Roman 2. And next is this question is given COEN whole 3, because a didentate ligand neutral molecule, so the charge is +3, cationic complex ion here, and this is Cn is -1, cyano group, and this -6, so total charge is -3. So this side, left side is +3 and right side is -3. That means what is the name? You can write simply ethane 1,2-diamine, but it is 3 times, so you should write tris. Tris ethane 1,2-diamine, cobalt 3, and hexacyano-chromate 3. Chromate because chromium changes to chromate and the charge that is 3, Roman 3, Roman numeral 3. Then what is the eyepiece name? 1, this one I told, and you can see what is its coordination isomer. Only you change cobalt here and chromium here and give the name accordingly. I hope it is clear. And coordination isomerism, it is very easy, and only two sphere you will find. You only interchange the ligand so that the left side should be positive ion and right side should be negative ion, so that there is no confusion at all. And I hope you will subscribe my channel B.L.DASH Short and Sweet in Chemistry. And thanks for watching my video. Again, thanks to all.